Hi everyone, welcome to lesson 7 of our exponential functions unit. Today we're going to take a look at solving exponential equations. In this lesson, you will learn how to solve exponential equations with the same base, with unlike bases, and by graphing. The important part of this lesson is the property of equality for exponential functions. Two powers with the same positive base and the base does not equal 1 are equal if and only if their exponents are equal. So if we were to take a look at an example, if I have 2 to the power of x is equal to 2 to the power of 5, then because the bases are both equal 0, this will only be true if x equals 5. So algebraically, if b is greater than 0 and b does not equal 1, then b to the power of x is equal to b to the power of y if and only if y equals x, or x equals y. I said that backwards. So let's take a look at an example. In this example, we have 3, a base of 3, to the power of x plus 1. That is equal to 3 to the power of 5. Because we have the same base, this expression or this equation is only true if the exponents are equal to each other. So that property of equality allows us to write x plus 1 and set it equal to 5. Then we can simply solve this. We'll take that 1 over to the other side, and in this case, x will equal 4. So not too bad. Let's take a look at b. Again, we have the same base of 6. And you might think on the left side that you don't necessarily see an exponent, but in fact, a single whole number without an exponent, the exponent is assumed to be 1. So again, because they have the same base, our property of equality allows us to write that 1 is equal to 2x minus 3. Let's take this negative 3 over to the other side. That will give me 4 is equal to 2x. I will divide both sides by 2. And this example gives me x equals 2. Moving on, let's take a look at C. And another example where we have the same base. That property of equality allows us to take the exponents and set them equal to each other. So 3x is equal to 2x plus 3. Solving this linear function, we can just move that 2x over, end up with a single x equals 3. So that is solving an exponential equation that has the same base. Let's move on to take a look at a couple of examples where the base is not the same. What you want to do here is make sure you focus on rewriting one of the sides of the equation as an exponent. We can see that for a, 5 to the power of x equals 125. Obviously, there's no similar base. But if we're familiar with our exponents, then we might be able to see that 5 to the power of x is equal to, we rewrite 125 as a power of 5 to the base of 3. Now we've created the same base, and that allows us to write x equals 3. Let's take a look at b. Again, we don't have the same base. On the left side, it's 4. On the right side, it's 2. So let's focus in and see if we can rewrite 4 as an exponent with a base of 2. Well, 4 is equal to 2 to the power of 2. But we do still have that entire number raised to the power of x. We don't need to change the base over on the right side, so we have x minus 3. Remember, power of a power. So that we simplify the exponents over here correctly. Power of a power says that I have to multiply these exponents here. This results as 2 to the power of 2x equals 2 to the power of x minus 3. Now that we've created the same base, we can rewrite the exponents and set them equal to each other. I'll take this x from the right, move it over to the left. I'll be left with an x equals negative 3. We'll take a look at example C. This is a situation where we have to manipulate both sides of the equation in order to get the same base. We can't have 9 match up with 27. But if we do remember some of our exponents, we can probably see that 9 can be written as 3 squared. We raise that to the power of x plus 2. The number 27 can be equated to 3 to the power of 3. And we raise that to the power of x. Power of a power means we're going to multiply all of these exponents. We have the same base, so we'll have 3 to the power of 2x plus 4. On the right side, we'll have 3 to the power of 3x. Now that we have the same base, we'll go ahead and equate those exponents in 2x plus 4 is going to equal 3x. And we'll take this 2x to the other side to solve. And I will have 4 is equal to 3x minus 2. That will give me x. So working with whole numbers, positive bases, not too bad. Let's take a look at some examples with fractions. So again, we see that we don't have the same base. On the left side, we have a base of 1/2, and on the right side, we have a base of 4. But here, you want to remember your negative exponent property. I can take 1/2 and I can change it to 2 to the power of negative x. If we reciprocate it, it will change the sign on our exponent. On the right side, 4 can be written as 2 to the power of 2. Now we've created the same base, and we can set our exponents equal to each other. Negative x is equal to 2. Let's simplify that negative sign, and we'll have x equals negative 2. Let's take a look at our final example of this type of exponential equation. And again, we don't have the same base, but we're going to manipulate that in that fraction. We're going to use that negative exponent property. So 4 we can rewrite as 2 to the power of 2, all raised to the power of x plus 1, equal to, well, 1 over 64, 64 is equivalent to 2 to the power of 6. We don't quite have the same base, but if we take the reciprocal of that, that will change the sign. We'll take a look at something that is 2x plus 2 is equal to 2 to the power of -6. Now we've created an equation that has the same base, and we can take our exponents and set them equal to each other. Let's move this +2 over to the right side, and we'll have 2x is equal to -8. Divide both sides by 2, and have x equals -4. Great. Now, there does come a time when it's impossible to write each side with a similar base. In this case, we probably want to take a look at using a graphing calculator or Desmos. So we're going to show you a couple of examples of something like this. If we have an equation that is given as 1/2 to the power of x minus 1 is equal to 7, we can see that we can't manipulate these two sides to have the same base. So what we can do is split that equation and create a system of two equations in one. So we take the left side of that equation and we make a function. Y is equal to 1/2 to the power of x minus 1. And we take the right side of that equation and we make a function of y equals 7. Once we do that, in order to solve for this on a graph, we graph two functions and we look to see where they intersect. So let's go ahead and go over to Desmos. Now that we have Desmos open, let's go ahead and split our exponential function into, our exponential equation into two functions, and we'll see where they intersect. So in the first part, our equation, our first function was y equals, let's put in some brackets. Now let's put 1 divided by 2 because that was the base. And tab over. Go down to this keyboard at the bottom. And when we click on that, we can select a to the power of b. So if I select that, and then in brackets, I'll put x minus 1, I believe, and close our brackets. So that was the left side of our exponential equation. And we can see that it is a decay equation. So now we're going to add the other side of the equation, which was just y equals 7. We don't quite see it, but y equals 7 is up here. So now we can see that they will equal each other right at the intersection point. So if I hold this bar down over here on the blue, I can make the thickness of the line much heavier. So I'll set it at 6. I'm actually going to go and do the same thing for the red line. That just helps me when I go and I take a look at the intersection point. So I can put the cursor right on the intersection point. It'll get highlighted over here. This is where I can label it. So I can click label. I can click point. I can name it point of intersection. And I can put the coordinates. -1.8. I'm just going to round that. Comma 7. So now you might be ready to go back and put it into your document. And in order to do that, we go up to the top right corner. There's an arrow in a box. Click that. We can export the image. When I click on export the image, you can click on medium again, make it nice and big. Download the PNG. It's up here as Desmos graph. And then I'm going to switch my share to look at my document. And I'd be able to go right into that space. I can insert. I'll choose an image. I'll upload it from the computer. And in my downloads, I'll search Desmos and select it, open. All right, so there you can see that is the solution to my equation. So I'm going to let you do the same thing with the other exponential equation. You're going to split it into two separate functions, graph them on Desmos, and find the intersection point. Okay. Okay, good luck with that. Let me know if you have any problems and reach out to me if you do.